Welcome to Brain Vision.
So this question wants us to explain effective nuclear charge and shielding. So the effective nuclear charge, or let me just start from basic explanation, that would be better. So the nucleus has the proton and the neutron, and the proton is positively charged and the neutron is neutral. It has no charge. Therefore, the effective charge on the nucleus is positive. And then, the nucleus is surrounded by shell containing electrons. And these are shells of electron. So, nucleus being positively charged, we attract electron that is negatively charged contained in the shell according to just the basic electrostatic law as a Coulombic attraction. So, but the thing is that the effect or the nuclear effect that is felt by electron in the first shell is greater than that felt by electron in the second shell, and the one in the second shell is greater than the one felt by the electron in the third shell. And that is because of what we call shielding. So the electron in the first shell shields the nucleus such that the nuclear charge that is felt by electron in the second shell is reduced because of the shielding from the electron in the first shell. So this concept where the nuclear charge is reduced because of a shielding by electron in the first shell, or because of the effect of electron in the first shell, or a particular shell, is called shielding, and that is what shielding is. So when the electron in the shell shields the nuclear charge such that the nuclear charge that is experienced by an electron in the next shell is reduced, we have what we call the screening constant. And the screening constants help us to calculate the effective nuclear charge. As a matter of fact, the effective nuclear charge is the charge that is felt by the electron in the subsequent shell after the shielding by the electron in the first shell, or the shell before that particular subsequent shell has been accounted for. So effective nuclear charge, so this will be the actual charge minus the charge screened by other electron. So if you subtract the charge that is screened by this first shell from the total charge of the nucleus, then you can determine the amount of charge that is felt by the electron in the next shell, and that is the effective nuclear charge.